Hello everyone, my name's Luke Sleeman. I'm a freelance Android developer. Today I'm going to be speaking about cool AI stuff from Japan. Actually though, I've got a confession. I lied to you all. I'm really going to be talking about machine learning stuff. Now, the reason I said AI and not machine learning is if you say you're going to talk about machine learning, people think your talk is going to be like this. Whereas, if you say AI, then they think your talk's going to be a bit more like this. And this is definitely what this talk is going to be about. Cool, fun things. I promise you, you will learn nothing. Well, almost nothing. I'm going to talk a little bit about a trip I recently made to Singapore for a machine learning experts conference sponsored by Google, and some of the new things announced in TensorFlow version 1.0. Then it's just cool stuff on from there on in. This talk is going to be a pretty informal one. Usually I like to give very polished presentations. I spend a lot of time preparing and putting them together. But this one's basically just going to be me talking about a bunch of stuff, and we're going to be watching fun videos. I've been giving a talk titled TensorWatt AI on Mobile over the past year, and you can also see this talk in my YouTube channel. And I was giving this presentation at the Google developer group in Taipei, and it just so happened that there was actually one of the developer relation managers from Google was present. And they came up and said, look, we're putting together a conference in Singapore for people that have been educating the public in machine learning, for machine learning experts. I said, well, you do know I am just a mobile developer and I barely know the first thing about machine learning. Like, you've seen everything I know in that half-hour presentation I gave on TensorFlow. And he said, look, that's okay, it's fine. Nobody knows anything about machine learning at this stage. We're all just figuring it out, so that's fine. And that is how I got a trip to Singapore to meet with a whole bunch of machine learning experts sponsored by Google. This is the hotel that they put us all up in. It was really nice. On the very first morning of the conference, I was down in the lobby just waiting for the free shuttle bus to take us to Google's offices in Singapore, and we're sort of milling around in the lobby and trying to sort of check out and see if there's some other people there that'd be attending the conference. And I'm looking at these people and I'm like, oh, there's a guy wearing a TensorFlow t-shirt. Like, he must be there for the conference as well. So I got talking to a bunch of the attendees, and I was speaking to, there was a lot of folks from Korea and Japan and Taipei and Taiwan and Hong Kong. One of the Koreans I was speaking to sort of looked at me and he's like, oh, okay, well, where are you from? And I'm like, oh, yeah, hi, I'm from Australia. And he said that, wow, from Australia, you really give you're giving this meeting a very international feeling. So it's not often as a sort of white, going on for middle-aged male guy that I'm the person bringing a lot of diversity and difference to the table, but it was a unique and interesting experience for me. This was the bus on the way to Google in Singapore, and it turns out that we actually did have a fairly diverse group of people from all around the Asia-Pacific region and the Middle East. I was one of the people that had flown in the longest to be there, but in the second row we have Ryan El-Zaib, the founder of GDG, the Google developer group in Lebanon, and she'd flown in all the way from Lebanon, which is almost as far as I came. Here is the Singapore Google office. You can tell I was very excited to be there. During the machine learning meeting that day, we learned about how Google is using machine learning internally, as well as some of the new features in TensorFlow. Each of the attendees also gave a lightning talk about what they've been doing in machine learning. And at the end of the first day, here I am having chili crab in the evening with some of the attendees from Korea. And I can assure you that Singapore's chili crab is great. The following day, there was a TensorFlow code lab open to the general public, run by some of the other attendees who actually did know something about machine learning. I attended as just a member of the public and actually sat down and did the lab, and it gave me a really great opportunity to learn a bit more about machine learning and TensorFlow. Now, this is the bit of the presentation where we actually do a bit of learning. During the Machine Learning Experts Conference, we had Kaz Sato from Google in Japan present some of the new features in TensorFlow 1.0. Now, for those of you that don't know about TensorFlow, it's Google's machine learning library. It's used internally by Google as well as being open source. There's a lot of projects that have been built on top of it out there on GitHub, and it's really getting a lot of adoption in the machine learning community. These are a few of the really exciting things that are part of TensorFlow 1.0. Firstly, there have been some really huge speed-ups there, which is very important because machine learning is a highly CPU-intensive thing. So any sort of progress or speed-ups or optimizations they can put in is going to make a big difference. There's also a bunch of new higher-level APIs. And because it's hit 1.0, this also means that TensorFlow's gone stable. It's got an API that you can rely on being there and not changing, and it's ready for full production use. The thing that excited me the most out of the new features for TensorFlow 1 are the higher level APIs. I've played around with TensorFlow a bit in the past and tried to do a few things with it, and really one of the biggest problems is that TensorFlow is very low level. If you just want to create a neural network and play with it, it was pretty much just DIY all the way up. You're building things out of very low level primitives. And this made it very hard to sort of see what was actually going on and experiment and learn. The new APIs make playing with machine learning very easy, and these were some of the things that I got to try during the code lab. Basically, you can build a neural network in a box and very easily sort of train it up off input data and then use it to make predictions with only a couple of lines of code, really. Another interesting part of TensorFlow 1.0 is the XLA experimental TensorFlow compiler. Basically, what it does is in TensorFlow, you need to build what are called models. And traditionally, if we want to run the models, particularly on mobile, you need to sort of start up the complete TensorFlow library and then use it to like construct and load up a serialized model and then use it to like interpret and execute the model. The XLA compiler takes a different approach. Basically, you feed in a TensorFlow graph, a TensorFlow model, and what it does is it spits out machine code. This can be very helpful for mobile. Previously, when I've done some playing around with it, it's been very difficult to integrate TensorFlow into mobile apps because you sort of need to build the entirety of TensorFlow, which comes with this build system and does a whole bunch of stuff with Python and different things like a tool called Bazel that uses for generating interfaces and so on. It's all very complicated. But with models compiled via the XLA compiler, I'm hoping we'll get a very clear separation between like the mobile app portion of the code and the TensorFlow portion of the code. And the only thing that the mobile app should need to depend on is the compiled version of the model. So also it should provide, again, some nice speed ups and optimizations, which again, very important in resource constrained environments such as on mobile. But that's enough learning for us. It's now time for some cool stuff. And the first really cool thing I saw and learned about at the Machine Learning Experts Day was actually the TensorFlow user group in Tokyo. I was very impressed by how much they've embraced machine learning and some of the really interesting things they've been doing with machine learning over there. Really, in Australia, a lot of people are just sort of starting to edge into machine learning and AI and sort of try and figure out what it's all about and, you know, what can we do with this and what does it all mean and is this something we should pay attention to? Whereas over in Japan, it seems like they're doing a lot of really fun and inspiring projects and using machine learning, not just for like sort of fun demos and toys, but for actual work. So the Tokyo TensorFlow user group regularly gets more than 300 attendees. And you can actually go and have a look at their sort of the page where all the meetings are organized by, and you can look at their past events. I was going through there, and they were running like a while ago just a 50-person code lab. You know, you could register and go and do a bit of coding and learn a little bit about machine learning. And they had 593 people register for this 50-person code lab. Another thing, at their initial meetup, they actually had the press and TV cameras at the first meetup with news crews reporting on what was being spoken about and what people were talking about. So this really, really blew me away. It sounds like just this one single meetup in Tokyo is you know, a lot more, getting a lot more attendees and a lot more buzz than even many conferences that I attend at. Now, the next cool thing I heard about as part of the Machine Learning Experts Day was the cucumber sorter. And this was something that was sort of went viral a little bit on the internet a while ago. Google did a few blog posts on it, and I'm sure many of you will have already heard about it. But basically the story is in Japan there was an engineer who wanted to take over his family cucumber farm and, you know, sort of pick up and take over the family business. And it turns out like one of the most labor-intensive parts of the cucumber farming was actually the grading of the cucumbers. So it turns out to sell them, you need to classify your cucumbers into different grades like L, M, B, S, BL, depending on like sort of their size and their shape and their color. You sell the best cucumbers to the highest places at the highest sort of prices, and the lowest quality cucumbers you sell them off really cheap in bulk. So the best cucumber grader was his grandmother, who was able to grade like thousands and thousands of cucumbers in a day. But it was a very labor-intensive process, and it was also like a very highly specialized process. It took a lot of time to like train people and get them consistently grading cucumbers. So he figured out, why not try and use TensorFlow and image recognition to build a system to automatically grade cucumbers? And here we have a video of it in action. Essentially what happens is he's got a couple of Raspberry Pis hooked up together, and they take a photo of a cucumber, feed it into a neural network that he's trained to grade them, and the machine basically classifies the cucumber grade and chucks it in different bins depending on its grading level. Now, we all know what a huge problem serving chicken nuggets is in today's society. They're weird shaped and oily and squishy and hard to pick up. And that's why at the TensorFlow user group in Tokyo, they have a nugget serving robot. This was something built and put together by an existing robotics company that makes and produces robot arms. And as a nice little demonstration of the flexibility and capability of their robot arm hardware, they had an intern just in a couple of days build this system that uses TensorFlow to have the robot recognize and serve nuggets. And the photo you can see here was when it was demonstrated at the TensorFlow Tokyo user group and was all serving nuggets to people. So here we have a video of it in action. There's a whole bunch of Japanese subtitles and whatnot that I can't understand. But essentially what's going on is it has a camera mounted on it, and the camera takes an image of what's sitting in front of it. It uses TensorFlow to recognize where the nuggets are, their position, orientation, and so on, and then the robot arm can pick up and serve the chicken nuggets. Now, this one has to be my favorite of all the cool AI that I'm presenting. I'm not sure how many of my listeners are familiar with Japan's pop idol culture. Certainly, I don't know very much myself. I looked it up on Wikipedia, and it seems to be all about basically manufactured starlets. Taking people and turning them into sort of pop idols and trying to go out there and market them and whatnot. And unsurprisingly, quite a few of these pop idols are on Twitter, and quite a few of them like to take selfie images. Now, this was a project done by a guy called Yoshihiro Sugi, who went and gathered over 100,000 idol selfie images and trained a neural network to generate fake pop idols. Now, remember when I said you're not going to learn anything at all in today's presentation? Well, I'm sorry, but actually I lied about that too. I'm going to explain how generative adversarial networks work because firstly, there's something that's a really interesting new area in machine learning that's got a lot of buzz around it. But secondly, because you can use them to generate fake Japanese pop idols. To have a generative adversarial networks, you basically need some training data and two separate neural networks, a generator and a discriminator. The discriminator's job is to tell the difference between a picture from the training data set and a fake one, created by the generator. And the generator's job is to try and produce something that's going to fool the discriminator. So you train both networks up at the same time, and the generator produces something, a really bad, poor image, and the discriminator looks at it and says it's false. No, this is not something from our set of training data. And you feed in some test data, some of the training data, and the discriminator says, yes, this is like a legitimate image from our test data set. But eventually, as they learn and adapt, the generator is going to get good enough to produce something that's going to fool the discriminator. But because we are responsible for this training and we know that the image came from the generator, we can update the discriminator so it improves itself and it gets better at recognizing fake images. We can tell it that, no, you were wrong, that was a fake. You keep on with the training, feeding in test data, the generator continues to improve, and the discriminator continues to learn how to recognize the fakes. And this goes on until eventually you actually have a system that's able to produce extremely realistic fake images. Here's what it looks like in practice. Now you can see it starts off with like really blurry, poor quality images that are being produced by the generator. And as the networks learn and grow and adapt, you can see these images become more and more realistic. Until eventually you're going to start landing up with something that's really surprisingly good. It's worth pointing out that none of these pictures, none of these selfies here are actually real people. They're entirely created and imagined by two neural networks working against each other. Apart from these kind of really fun demo projects, the other thing that really impressed me is some of the use Japan was making of machine learning for real, actual business use cases. So what I'm going to do here is show you a demo that was built for an auction website to recognize images of cars. Now, it takes a fair time to run, so I'm going to start it up, and then I'm going to explain what's actually going on here. Basically, this is an actual live website you can go to out there and try. And what happens is you have to upload some images of a car for sale. And these are some I've just taken off the internet. So essentially, this website was built for a online car auction website, one particularly used by a lot of car dealerships. And one of the biggest problems that they have when they want to go list and sell cars on the website is that it takes a lot of time to set up the description of the car and like enter all the details and tag all of the images and say, oh yeah, this is a white Toyota Corolla 2003 model, blah, 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 blah. So instead they thought, why don't we use AI to try and recognize what's being shown in the images, and then we can use it to automatically like recognize what the images, what part of the car the images are of, and also be able to sort of figure out things like branding and what model of car it is and what make of car it is. So rather than having to have somebody enter all of the details about a particular vehicle, you just take the photos, upload the photos, and then have the AI automatically categorize those. And because it was an existing auction website, they obviously had a really large existing data set that they could learn off and use to train up their neural network. And here we are. What's happened is it's gone through and it's taken a look at all our images, and it's with a fairly high degree of confidence being able to determine what they're all about and what they all mean. Now, this is just like a demo version of the website. What it is missing is the ability to actually, from these images, tell you exactly what model and make of car it is. But you can see here it has been able to recognize what's in each of the images and what part of the car they're showing. The Drone Asset Management was a partnership between AeroSense, a drone company, and you can see that's actually a photo of one of the AeroSense drones there on the slide. And you can see it's got a pretty beefy camera at the bottom of the drone that faces downwards. And BrainPad was the second part of this partnership. BrainPad's a Japanese machine learning company. And essentially what they worked on is using aerial imagery taken by the drones to recognize and identify the number of cars on a worksite. They used an adapted and existing TensorFlow model called Inception v3 that has been partially trained up to be able to like differentiate and start the process of being able to recognize things. And they used what's called transfer learning. So that means you take up a partially trained model and then you train it on a specific data set and a specific problem domain, in this case recognizing cars. Now unfortunately I don't have a really cool video to show you of this. Really all we've got there is a Google translated blog post in Japanese, but they said basically what it's for is to automatically manage materials at the material storage site and monitor the facilities and plan to positively utilize it for development of new services and so on, which certainly sounds like something very useful and very businessy. This is not just a sort of cool, fun, wacky demo of let's generate pop starlets or pick up chicken nuggets. This is actually driving business value and something that's going to be very useful for various companies out there. Now, before I finish up, we have one bonus cool thing, and this one actually comes from Hong Kong and Korea, not from Japan. It was done by a guy called Sung Kim from Hong Kong University, and it's basically automatic code generation using machine learning. So I know a lot of us software developers like to think that our jobs will be when the robots come and take over everybody's job and make everybody unemployed. We're going to be like the very last people out of a job. But look at this and be very afraid. Sung Kim basically started by asking the question, as a coder, how much of what you write is actually creative? How much of what you do is actually unique? And how much of it's just boilerplate? And because I'm a Java Android developer myself, I can tell you the answer is that quite a bit of it's boilerplate, actually. So this applied a lot of machine learning techniques that have been used on understanding and dealing with human language like English or Chinese or French, and tried to apply them to computer language. And he did a number of pretty interesting things. He worked on generating the next couple of lines in tokens. So looking at the past sort of 3 lines of code in an integrated development environment, can we figure out what the next line of code is going to be? And it turns out that actually you can most of the time. You can give a pretty decent prediction on what people are going to type next. This slide that I'm showing here is from his presentation. It's about using the system to automatically patch and fix bugs. So basically what it does is it takes description of the bug and goes and produces a patch that will fix the issue. And you can see, look, it's not totally accurate. It patches 27 issues correctly out of 119. But really, that's still pretty amazing, actually. He also has a lot of interesting future potential work that he could be doing with this system. One thing that really interested me is he suggested that it could be used for doing automatic translation of, for example, iOS apps over to Android or conversion of Android apps to iOS. And applying this machine learning to this struck me as a really interesting idea. If you go looking around the internet, there are various tools out there already that can automatically convert like Java code to Swift or Objective-C or whatever. But they don't really take into account the different platform differences and conventions in the ways that apps should act differently on Android or iOS. And it struck me that really machine learning could actually take that into account. The other thing is, one very important thing when you're doing machine learning is you need to have a huge training data set. And with iOS and Android app conversions, there's a lot of apps that are being built for both platforms out there at the moment. So there is a very large data set you can train off. Another thing that he mentioned it could be used for is the automatic marking and grading of student assignments, which I thought was a very interesting use as well. Actually having tutored Java way back when at university, I was like teaching some subjects on Java, just helping to run tutorials. And part of my job was to grade all of these student assignments. And it was a lot of work. Like, it's just before the exams and you've got like 30 or 40 different Java assignments you've got to go through and consistently grade and evaluate and mark. It takes a long time. It's very labor intensive. If you could do that automatically using machine learning, students could get a lot quicker feedback on what they're doing well and what they're doing wrong, and it could help them improve themselves a lot faster. It could also take a huge workload off university teachers and so on. So that concludes our presentation for today. If you have any questions for me, please leave them in the YouTube comments and I'll try and get back to you as quickly as possible. I hope what you've seen has piqued your interest and you've found it, like I did, very interesting and exciting and inspiring. And I hope it also inspires you to have a go at machine learning and play around with it and try and do something interesting yourself. Thank you.